Welcome to video topic number 3, graphing functions. What we're going to do today is we're going to look at these two functions. We're going to graph them and in a couple of different ways. So the first thing we need to know about graphing functions is what we mean by domain. And if you remember, the domain is the allowed x values. So we might know to exclude some x values because they don't make sense, like negative numbers might not make sense. Or they might not be defined, like we can't divide by 0, so 1 over x has an implied domain. But anyway, we're going to talk about the allowed domain, and that is the x values that we're going to consider for the problem. So the first type of problem we're going to talk about is we want to graph a function with an unspecified domain. That means we don't have any idea what the x values are. So what do we do in that case? Okay, I have down here written some things that we're going to do for each of these functions. The first thing I want you to do is enter these two functions in your calculator. And when you get that, you could pause that. When you get that, you could press play again. Well, that's funny. I didn't need to pause that. You needed to pause that. Well, anyway, here I have them in. And the first thing I want you to know about is the highlighted equal sign. The highlighted equal sign is going to tell me which functions it's going to graph. So I'm going to start off with just the first graph highlighted. I'm going to look at these one at a time. So to get sort of a general screen, standard screen, Zoom 6 is a good choice because it's fairly big. I like Zoom 4 if I kind of know what's going on, but I don't know anything about this. So I'm going to choose Zoom 6. Zoom 6, and it's going to graph that first function. It kind of looks like a line. If I look at this, I have to know a little bit about a fifth degree polynomial, that what's going to happen with the end behavior. It's odd, so it's going to start. And this is a positive, so it's going to have generally a positive slope. So that's generally a positive slope, but I'm going to expect it to have a little bit of wiggles. So the thing that I might try is just to zoom out. Let's just see what happens if I choose Zoom 3 and hit enter. Okay, now I can see where it wiggles again, and that's going to tell me that I probably should be looking at that area right there. Okay, there's a couple of ways to do that. A quick way to do that is to use box. Since I have a little bit of a space, I'm just going to choose Zoom 1. Maybe I didn't hit Zoom 1. I'm going to try that again. Zoom 1. Oh yeah, I did hit Zoom 1. Anyway, I'm going to see that my little cursor, I'm going to put it up into the general area that I want. So I wanted to capture that area. So there's the upper left-hand corner, and I'm going to come down so it captures the whole thing. It's going to make a little box right there. It's too far to the right. I only really want to look at this area. If I hit enter, it's going to graph that area. Okay, now I can see I pretty much have all my graph because I got this change. If it was a cubic, it might just go like this, but it's fifth degree. So there's a good way to graph this function. I used standard, I zoomed out, and then I boxed it. Okay, we're going to look at the other function now. So go back to y equals and unhighlight this one and highlight the other one. Now we're going to go back to Zoom 6 and see what we see. This one is a fourth degree polynomial, so we know that it's going to have end behavior that both goes up. It's positive, right? So it's like this. I guess you could see me like this. It's end behavior, it's positive, it goes up. So it looks like that's kind of caught a little piece of it here, and I caught a little piece of it there. So it depends what I want out of this problem. Perhaps I want to find out what's going on around 0. Like what is happening there? It looks like it just comes up and it crosses the x-axis in one place, but I don't know. So I'm going to try to change my window settings so I could do that. I could just zoom in right there at 0. That might be a good choice. But let's see what happens with, I want you to know how to do these other things right here. So I just did the standard. I'm going to put -1 and +1 in for my window settings. So it's -1 and +1. If you remember, the graph looked like it was kind of near 0 there. Then I'm going to graph it again. Okay, so you know that didn't show me very much because I didn't use zoom fit. Okay, I just changed my x values. The y values are still huge. Now what zoom fit's going to do is take that same domain from -1 to +1, and it's going to make this graph fit. So it's going to put the maximum at the top and the minimum at the bottom. So just hit zoom 0, and we'll see that that has a little bit better view of that graph. Okay, so remember when using zoom fit, you have to really set the x and the calculator sets the y. So that's what we did. Now I can see that the graph actually looks like it might hit the x-axis in more than one place. So I could do a little bit more analysis on this graph if I wanted to find out what those x values were. Perhaps I wanted to see more of the other graph, and I remembered that my original x and y window was set at -10 and +10, so I'm going to set it back to -10. And my x max I'm going to leave at 1 because it's going to capture pretty much the whole graph that I saw. And I'm going to hit zoom 0 again. That's zoom fit. And it's going to catch the other part of the graph really well. So it still catches this right-hand side of the graph, but it catches this lower part. Maybe I'm really interested in that lower part right there. So here we have, once again, the standard window to get started. I could adjust my x and y mins and max, or just my x min and max, and then I could let the calculator set the y by using zoom 0. And I did that in 2 cases. Now what's really nice, and what happens a lot of times in calculus, is that we know what the domain is because we're solving a problem. Or it might just tell us, but we might be solving a problem where we know that the only feasible answer for x is between 0 and 0.5. So if I wanted to evaluate this function around those values, then I'm just going to hit the window, and I'm going to set my x minimum and my x maximum at those domain endpoints. So that's 0 to 0.5, 0.5, and hit zoom 0. And now it's going to graph that part of the graph, and I can see very clearly what's going on between 0 and 0.5. That's pretty much it for graphing. It could get kind of complicated if you can't see your graph, but you could try zooming out. You could try adjusting your x. You can try even adjusting your y's. I don't normally do that. But that's the end of this lesson. See you next time.